Okay, so in this lesson, this is basically a review of solving quadratic equations by using the square root property. And so again, mainly what we're going to do here is just work some problems. But the lesson that dealt with this is in a previous module. So if you need to go back to that lesson, make sure you do that. But again, this is just going to be a review of solving, and these are the quadratic equations we're going to solve. So if I'm going to use the square root property, remember I've got to have some expression squared equal a constant. So I must have a constant on the other side, and then the expression is being squared is going to be on the left. So basically, you saw that one of the properties to solving a quadratic equation that looks like this, x squared equal a constant, was that we would take the square root of both sides, and don't forget a plus or minus, and so this would become x equal plus or minus the square root of c. And so we could also saw that we can write this as x equals the square root of c, comma, x equals negative square root of c. But basically the point being that if I'm going to use the square root property, I've got to have some expression squared equal a constant, then I take the square root of both sides. All right? Okay, so let's look at some examples. So make sure you read the directions. Directions will say solve by using the square root property. So solve each equation, and these are going to be quadratic equations. So solve each quadratic equation by using the square root property. Okay, so number one. So let's suppose number one, I had this. I had x squared equal 81. All right, now that's the easy kind. That's the easiest kind. In fact, you could even look at this equation and determine the solutions by inspection. So what times itself is 81? Well, obviously 9 and negative 9, right? So 9 and negative 9. All right, so basically you would take the square, let me go ahead and rewrite this over. You would take the square root of both sides, because you're trying to get x by itself. Right now you have x squared, so the opposite of squaring is the square root. But don't forget the plus or minus on this side. So the square and the square root into each other. So you get x equals plus or minus square root of 81. And since 81 is a perfect square, I can write this as x equal plus or minus 9. All right, so don't leave your answer like this. Make sure you simplify the radicals if possible. Okay? Radicals when possible. All right, so simplify the radicals when possible. All right, now what if we had this? So what if we had x squared equal a negative 81? Now, I want to remind you about this. This right here, that's a real number. All right, that's a real number. Now remember, real numbers can be rational or irrational. This is rational because I can write 9 as 9 over 1, negative 9 as negative 9 over 1. All right, so that's rational. So this is a real number. It's a rational real number. Now over here, there is no real number times itself that's a negative 81. In fact, remember, any real number times itself is either 0 or positive. But you may remember something from the previous lesson. So in the previous lesson, remember you learned about the imaginary unit. And so the imaginary unit, if I have the square root of a negative 1, by definition, what do we define this as? We define this as the imaginary unit I. Okay, so that's defined as I. So remember now, this becomes imaginary. So this is real, this is imaginary. Okay? So now we're dealing with a different type of numbering system, imaginary units. And so all of this, though, is part of a number system called complex number system. But for this, just keep track of what I'm talking about as we go through this, because this is supposed to be a review of something that we've learned in a previous lesson or lessons. So if I get x by itself over here, I'm going to go ahead and rewrite this over, and I take the square root of both sides. Don't forget to get plus or minus. The square and the square root undo each other. So I get x equal plus or minus the square root of a negative 81. Don't make the mistake and say that's plus or minus 9. That's not true. Okay, this is plus or minus 9. The square root of 81, the square root of 81 is 9. The square root of negative 81 is not 9. All right, so let's think about that. So I know that I can rewrite the square root of a negative 81 as the square root of a negative 1 times the square root of 81, right? Okay, and I know by definition the square root of negative 1 is I, and I know that the square root of 81 is 9, so that's just 9i. And we always tend to write I at the end, like that. Okay, so that's 9i. So this becomes x equals plus or minus 9i. Now remember our discussion in previous lessons. This is a real number. This is an imaginary number. Okay, that's not a real number. That's a real number. You can think about this as being a real number, like $9. Okay, this is not a real number. What is 9i in terms of what you're used to thinking about in terms of numbers? All right. Okay. Now let's look at number 3. All right. So this is what I need to review with you before we go on. The idea of that the imaginary unit. Okay. All right. Number 3. Let's suppose we had this. So number 3, let's suppose I had x squared plus 7 equals 0. X squared plus 7 equals 0. All right, so remember I want to solve this quadratic equation. And if I'm going to solve this quadratic equation, it has to first of all look like this form. Some expression squared equal a number. All right? And notice that whenever you're using the square root property, you remember the form of a quadratic equation is this: ax squared plus bx plus c equals 0. So when I'm using the square root property, what's happening is that you won't see the x term. All you'll see is an x squared and a constant, which is what you see here, right? You don't see that x term. So then if that x term's not there, if that first degree term is not there, then I can use the square root property. I just have to first of all get it in this form. So to get this to that form, remember I have to have that constant on the other side. So I got to subtract 7 from both sides, and so I get x squared equal a negative 7. Now remember, you're trying to get x by itself. The opposite of squaring is to square root. So I'm going to go ahead and take the square root of both sides, just like this. Don't forget the plus or minus. All right, you can have a positive square root and a negative square root. The square and the square root undo each other, so you get x equal plus or minus the square root of a negative 7. All right, let's talk about that. Don't leave it like this. You need to recognize, hey, I'm taking the square root of a negative number. I know that the square root of a negative 1 is defined to be I, so I need to use I in my answer. Okay? You have to use I in your answer. So what I would do is, now somebody can go from here to the answer. Now that's fine. But if you need to, for right now, you may want to rewrite the square root of a negative 7 as the square root of a negative 1 times 7, right? Negative 1 times 7 is negative 7. And then let's break this down to the product of two square roots. So that's the square root of a negative 1 times the square root of 7. The square root of a negative 1 is defined to be I. And I can't simplify the square root of 7, so I'm going to leave it like that. Okay, there's no perfect square that goes into 7 other than 1. Now there are two ways you can write this answer. You can write it as plus or minus I square root of 7, which is probably the way I would do it. Or you can say plus or minus the square root of 7i. Now let me warn you about this. You better make sure that that I does not look like it's underneath the radical, because some of you have a habit, some students have a habit of writing this, the square root of 7i, like that. Well, that looks like that I is under the square root, and it cannot be, because I and negative 1 are not the same thing. The square root of negative 1 is I. So if it looks like this and I can't tell, I'm going to assume that it's underneath and it's not correct. All right, so this is not correct. Those two are not the same thing. So to be on the safe side, what I would do, whenever you have a square root in the answer and an I, I'd put the I in front of the square root. Okay? All right, so make sure you're aware of that. You're going to be very upset if you do this, if you do like this, and I take points off because I can't tell where that I is. So what you do is just write it like this. Now I can tell where it is. It's outside of the square root. Okay? All right. Now in MyMathLab, you're going to have to write it like this. You remember in MyMathLab, you have to write it as two separate solutions. So I square root of 7, comma, I, negative I square root of 7. Okay? So I square root of 7, negative I square root of 7. All right, number 4. All right, number 4, suppose we had 2x squared plus 36 equals 0. 2x squared plus 36 equals 0. All right, so the question becomes, can I go, at some point, can I write this like this, some expression squared equal a number? Yeah, because the x term is missing. You don't see an x term, you see an x squared and a constant. So I can easily get this to look like this. All right. So let's go ahead and subtract 36 from both sides first, though. Make sure you do that. And so I get 2x squared equal a negative 36. Then dividing both sides by 2, I get 2 divided by 2 is 1, so I get x squared equal a negative 18. All right, so that's where I'm at. So now this looks like this. So the next step is to take the square root of both sides, because remember, you're trying to get x by itself. Right now you're squaring. The opposite of squaring is just take the square root. So I'm going to take the square root of both sides. Don't forget your plus or minus, because you get a positive square root and a negative square root. The square and the square root undo each other, so you get x equal plus or minus. All right, now let's talk about the square root of a negative 18. Remember, first of all, you have that negative under the radical. All right, so you know you're going to have an I in your answer. But do you all agree? What I would do is I would work this out. So I know that the square root of a negative 18 is the same thing as saying the square root of a negative 1 times the square root of 18, right? And from previous lessons, I know that I can simplify the square root of 18. What perfect square goes into 18? The largest is 9. So I can write this as I, square root of negative 1 is I, times the square root of 9 times 2. And then I can write this as I times the square root of 9 times the square root of 2, right? And then I know that the square root of 9 is 3. Now, here's how I'm going to go ahead and say I times 3 times the square root of 2. Y'all agree? All right. Now, the way I would write this, you see how right here we wrote this as I squared root of 7, negative I squared root of 7? And then notice all of a sudden I have an extra factor here. I just don't have I squared root of 2. I have I times 3 times the square root of 2. I would put I between the 3 and the square root of 2. So in other words, I would write it as 3I square root of 2. All right. So it kind of makes sense based on what we did earlier. Remember how I wrote this as 9I and not I9? An I and I, right? Okay. So you put the I at the end. So same thing here. See, if I didn't have the square root of 2, that would be 3I, right? Since I have the square root of 2, put it at the end. Put the square root of 2 at the end. So put I in the middle. So just try to remember that. Make sure you do that. It makes things a lot easier to read. So this will be plus or minus 3I square root of 2. Now, in MyMathLab, you could also write it as 3I square root of 2, comma, negative 3I square root of 2. Okay? Now remember, those are imaginary solutions. These are not real solutions. Real solutions are numbers that you've been dealing with since first grade. All right, so those are real solutions. Positive 9, negative 9, 5 in the previous example, previous lessons you've done, like 5 square root of 7, 2.6, things like that. When you have I involved, those are not real solutions. Those are imaginary solutions. Imaginary solutions. So these, let me go ahead and make a note of that. These right here are imaginary solutions. Imaginary solutions. All right, don't forget, those are imaginary solutions. You have that I involved. Okay, number 5. All right, suppose in number 5 we have this. We have 2x plus 4 squared equal 36. 2x plus 4 squared equal 36. Okay, well, I can deal with that. Since remember, you already have in that form, you have some expression squared equal a number, right? You already have that form. So I'm going to go ahead and take the square root of both sides, just like this. All right, square root of both sides, I'm going to get plus or minus, and then the square and the square root undo each other. So I get 2x plus 4 equal plus or minus. Now 36 is already a perfect square. So the square root of 36 is 6. All right, now this is how you're going to do this. So you see how I went from the square root of 36 and 36 was a perfect square. So remember this 6 here, square root of 36, then is a rational. I'm going to get rational solutions. Whenever you get rational solutions, you want to do it this way. Okay, you want to rewrite this like this. 2x plus 4 equals 6. 2x minus 4 equal, 2x plus 4 equal a negative 6. Okay, so 2x plus 4 equals a positive 6. 2x plus 4 equals a negative 6. All right, and then you're going to solve for x. So I have to subtract 4 from both sides. So I get 2x equal 2. Divide both sides by 2. One of my solutions is 1. So that's your first solution. That's a rational number. Those are rational solutions. Subtract 4 from both sides. I get 2x equal a negative 10. Divide by 2. My other rational solution is negative 5. All right, so your solutions are x equal 1, x equal negative 5. That's how you have to write this. Whenever you do this and this is a perfect square, you're going to get rational solutions. So you have to split it apart. So you have to tell me exactly what they are. They are 1 and negative 5. All right, so notice that looks different from a previous lesson as well. So remember in previous lesson where we had the square root of 20, so you may recall that. Well, remember 20 is not a perfect square, so you end up with after you reduce this, you end up with still a square root. So remember that was irrational. So remember we talked about irrational as well. So that's irrational. So you just wrote it out, you just left it like that. Okay? But these are not irrational solutions. Those are rational solutions. So you have to write it like this and actually tell me what they are. All right. Okay, that was number 5. Now let's suppose I do the same problem, but instead, let's suppose it was a negative 36. Negative 36, okay? So this was a positive 36, this is a negative 36. Let's see how this would be different. Okay, so I already have that form where I have some expression squared equal a number. Some expression squared equal a number, so I can go ahead and take the square root of both sides. All right, so no big deal. I knew I could do that. So I'm going to take the square root of both sides. Don't forget plus or minus, right? Okay, so the square and the square root undo each other. So I got 2x plus 4 equal plus or minus. Now you got to remember the square root of a negative 36. All right, that's not a real number. That's an imaginary number. So remember you can write this as the square root of a negative 1 times the square root of 36. Square root of a negative 1 is I. Square root of 36 is 6. So that's 6i. That becomes 6i. Okay? All right, now notice this right here was a real number. In fact, it was imaginary. So this is how you worked it out. Here, this is not a real number. So I would do this just like I did that example I showed you a while ago, just like this. I would work it out. I would bring the constant to the other side and divide by whatever that coefficient is. So in other words, I'm going to subtract 4 from both sides, just like this. And so I'm going to get 2x equal negative 4 plus or minus 6i. All right. Then I'm going to rewrite this over. Then I'm going to divide both sides by 2. And so I get 2 divided by 2 is 1, so I get x equal. All right, now I'm going to go ahead and rewrite this over, but my math lab is not only going to say simplify the radicals, but it's also going to say reduce when possible. I can reduce this. See that negative 4, the 6, and the 2? They're all divisible by 2. So in other words, I can write this as negative 4 divided by 2 plus or minus 6i divided by 2. And then negative 4 divided by 2 is a negative 2. And then 6 divided by 2 is 3. And so that's the answer you want to write. Okay, so so reduce if you can. Reduce if you can. Okay? All right, now my math lab, you can also write it as negative 2 plus 3i, comma, negative 2 minus 3i. Okay? And remember, these are imaginary solutions. Imaginary solutions. All right, imaginary solutions. You have that I involved. Okay, number 7. All right, let's suppose we had this for number 7. So number 7, let's suppose we had, let's see real quick. All right, let's suppose we had this. 6x minus 9 squared equal 45. 6x minus 9 squared equal 45. Okay? All right, so I already have that form where I have some expression squared equal a number. So I'm going to go ahead and just take the square root of both sides because I'm trying to get this expression by itself first. So since I'm squaring, the opposite of squaring is to take the square root. So I'm going to take the square root of both sides, just like this. Don't forget the plus or minus. Many people forget about that. So the square and the square root undo each other. So I'll have the expression 6x minus 9 equal plus or minus the square root of 45. Now, is 45 a perfect square? No. So this is going to be irrational solutions. Okay, it's not imaginary because you don't have a square root of a negative number. All right. So it's going to be a real number, either irrational or rational. So this will be irrational since 45 is not a perfect square. And so you're going to write it differently than you did the rational one. All right, so you're going to add 9. Oh, first of all, let's go ahead and simplify the square root of 45. So the square root of 45, a perfect square that goes into 45 is 9. That's the largest, so 9 times 5. So the square root of 9 times the square root of 5, so that's 3 square root of 5. So that's what goes here, 3 square root of 5. So this will be 6x minus 9 equal plus or minus 3 square root of 5. Now let's add 9 to both sides. And so combine like terms, I get 6x equal 9 plus or minus 3 square root of 5. And then the next step is to get x by itself. So the next step is to, just going to write this over. So the next step is, since I'm multiplying both sides by multiplying this x by 6, the opposite is to divide by 6. Divide both sides just like this. X equal 9 plus or minus 3 square root of 5 divided by 6. All right. Now, let me tell you different ways of writing this, okay? So you need to reduce when possible, right? So reduce if possible, okay? All right. Now, what that means is this. If I look, I'm going to go ahead and rewrite this over. If I look at the 9, 3, and 6, I look at 9, 3, and 6. So if I look at 9, 3, and 6, what do 9, 3, and 6 have in common? What's the greatest common factor of 9, 3, and 6? And don't say 1, and don't say 18. We're not talking about the least common multiple. We're talking about the greatest common factor. So what's the largest number that goes in a 9, that goes in a 3, and it goes in a 6 at the same time? So the answer is 3, right? So I can reduce this. So listen carefully how I'm going to reduce this. I'm going to go ahead and rewrite it like this again. So 3 goes into, remember they all have 3 in common. So 3 goes into 9 3 times, 3 goes into 3 1 time, 3 goes into 6 2 times. And so this becomes this. So that's going to equal 3 plus or minus 1 square root of 5 is the square root of 5 divided by 2. All right, so reduce if possible, okay? Reduce if possible. All right, now, something else you could have done was this. Okay, so listen carefully to this part. So you could have done this. Remember how in some situations we broke into 2 fractions? So here's another way. You could have said 9 divided by 6 plus or minus 3 square root of 5 divided by 6, right? And then reduce like that. So what's 9/6 reduced? Well, that's 3/2, which is what you see here. Plus or minus, and then reduce this, that's 1/2 as well. So that's square root of 5 divided by 2. which is what this is. So notice this right here, since the denominators are the same, that becomes 3 plus or minus square root of 5 over 2. Okay, so those are just different ways of writing this answer, but you are going to be asked to reduce if possible. So you have to either write it like this or like this. And on my math lab, you're going to have to write as two separate solutions. So I would just go ahead and leave it with as one fraction. In other words, 3 plus the square root of 5 over 2, comma, 3 minus the square root of 5 over 2. That would be my math lab. All right? And if you want to, you could have also said this right here, 3 halves minus the square root of 5 over 2, comma, 3 halves plus the square root of 5 over 2. All right, so those are all different ways of writing the same thing. But keep in mind that for this right here, you had to recognize that these three numbers are all divisible by 3 and then reduce. Now, you know, if this is worth, let's say, 10 points, you'll get most of your points by getting to that point. Some students forget about going further. You need to try and remember that. If possible, go further. Reduce if possible. Okay? All right, so that was number 7. Now let's get number 8. So number 8, let's suppose we had this. Number 8. Let's suppose we had 2. Let's do this. Let's just do this. Let's suppose we had 3x minus 1 squared plus 7 equals 23. So 3x minus 1 squared plus 7 equals 23. Okay, so remember, we want to try and get this form, right? So some expression square degree number. Does that look like this? No, because you have that 7 here. So I got to subtract 7 from both sides first, right? So I get 3x minus 1 squared equal, and then what's that, 16? Y'all agree? All right, 16. Now, does that look like this? Yes. So now I can take the square root of both sides. Let me go ahead and rewrite this over. I'm going to take the square root of both sides, because right now I'm squaring, right? The opposite of squaring is the square root. Don't forget the plus or minus. The square and the square root undo each other. So I have the expression 3x minus 1 equal plus or minus. Now, 16 is a perfect square, right? And what's the square root of 16? 4. Now, be careful. This is not true. Some students, for some reason, want to say the square root of 16 is the square root of 4. That's not true, right? Square root of 16, the square root of 16 is 4. Okay, so don't make that mistake. Now notice that square root of 16, that 16 is a perfect square, so I ended up with 4. That's irrational solutions. Those are rational solutions. And so remember, when doing the rational solutions, you gotta go much further with them than you would normally do with irrational solutions. So in other words, and this is rational, you are expected to write this as two separate rational solutions. So 3x minus 1 equals 4, and 3x minus 1 equals a negative 4. And then you solve each linear equation for the variable x. So I add 1 to both sides, and so I get 3x equal, what's that, 5? Divide both sides by 3. I get x to be 5/3. So there's one of your solutions, one of your rational solutions. Over here, add 1 to both sides. I get 3x equal a negative 3. Divide both sides by 3. I get x to be negative 1. So there's your other rational solution. Okay? All right, number 9. Suppose in number 9, I had this. I had 3x minus 1 squared plus 7 equal, let's say, negative 23. Okay? Negative 23. All right, well, so remember, I have to get in that form, right? Some expression squared equal a number. So just like we did in number 8, I'm going to subtract 7 from both sides. And so I get 3x minus 1 squared equal, what was that, negative 30? Okay, negative 30. And then I'm squaring this expression. So I got to get this expression by itself. So I'm going to do the opposite of what squaring is. So the opposite of squaring is square root. All right, so I'm going to go ahead and rewrite this over. I'm going to take the square root of both sides, plus or minus. The square and the square root undo each other, so I get 3x minus 1 equal plus or minus the square root of a negative 30. Okay? Now notice I'm taking the square root of a negative 30, right? Okay, so that's going to be that I. So that's going to be imaginary solutions. I'm going to end up with imaginary solutions. But I need to simplify the square root of a negative 30. First of all, I need to rewrite it as an I. Don't leave it as a negative underneath here. You need to remember that the square root of a negative 1 is equal to I. You have to use that fact. So the square root of a negative 30 is the square root of a negative 1 times the square root of 30. Okay? Now ask yourself, is there a perfect square other than 1 that goes into 30? The answer is no. Okay? There isn't any. So this becomes I square root of 30. So that's what I'm going to write here. So that's 3x minus 1 equals plus or minus I square root of 30. Okay? All right, now, the next step is to get, remember, you got to get x by itself. So you're going to add 1 to both sides, and so I get 3x equal, this is 0, so I get 3x equal 1 plus or minus I square root of 30, right? And then one more step and you're basically done. So the next step is to divide both sides by 3, just like this. And so I get x to be 1 plus or minus I square root of 30 over 3. All right. Now, so remember, you want to reduce. If you can go further, you reduce, which I cannot because that's a 1. This coefficient right here is a 1, and that's a 3. So the GCF of 1, 1, and 3 is 1. So there's really nothing you can do. And don't make the mistake and say 3 into 30 is 10, because that's not 30. That's the square root of 30. The square root of 30. The square root of 30 does not equal 30. So don't make that mistake. Okay? You can't reduce that. So that's it. Now in my math lab, so these are some other ways of writing the answer. So you could say 1 plus I square root of 30 over 3, comma, 1 minus I, don't forget the I, square root of 30 over 3. Or you can write as two separate fractions. You could say 1/3 plus or minus I square root of 30 over 3. Okay? Or you can say 1/3 plus I square root of 30 over 3, comma, 1/3 minus I square root of 30 over 3. So these are all just separate, different ways of writing this answer. Okay? Now, what if I had this? What if I had this? So notice that 8, 9, so 8 and 9 right here, they almost looked alike, right? And number 10, let's suppose this is number 10. 3x minus 1 squared minus 7 equals negative 23. Okay? Let's say we had that. Okay, well, again, I have to get into the form where I can use the square root property, right? So it's got to, first of all, look like this. So I got to add 7 to both sides. And so when I do that, combine like terms, I get 3x minus 1 squared equal a negative 23 plus 7 is a negative 16. All right. Then divide, taking the square root of both sides, because remember, trying to get x by itself. I'm going to get x by itself. First of all, I've got to get this by itself, so which means I got to get rid of that square right here. And the opposite of squaring is to take the square root of both sides. So take the square root of both sides. Don't forget plus or minus. So the square and the square root undo each other. So I get 3x minus 1 equals plus or minus the square root of a negative 16, correct? Now remember the square root of a negative 16. 16 is a perfect square. What's the square root of 16? 4. So what's the square root of a negative 16? 4i, right? 4i. So that's the square root of a negative 1 times the square root of 16, which is I times 4. That's 4i. All agree? Okay. So this becomes 3x minus 1 equals plus or minus 4i. Now, here's the question. Are these real solutions? Real? The answer is no. They're imaginary, right? So these are going to be imaginary solutions. All right. So then I've got to get x by itself. So I'm going to add 1 to both sides. So I get 3x equal 1 plus or minus 4i. And then finally divide by 3. Divide by 3. I get x to be 1 plus or minus 4i divided by 3. And that's it. So notice the similarities between 10 and 9. 10 and 9. See the similarities? right here. So let me get to it. Okay, you see? All right. So 8, 9, and 10, I use the same expression on the left side that you saw. All right, so go back over these 10 problems, and that should help you with the lessons that deal with this topic. So that is, if I can get to it, that was a quick review on solving quadratic equations using a square root property. Notice though, in this one, we dealt with imaginary solutions and we dealt with irrational solutions, which were real. So these are real solutions. So real solutions, you'll get either irrational or you will get rational. Okay? All right, so that's the end of this review.